Yeah. So we are starting with our class, and this is what is the code that we were working on, and I guess we were over here, right?
Yes, ma'am.
So we were writing this cout statement yesterday to give an information that angles should be inputted. So input angles, angle of each force vector, I would write angle of force vectors, angle of force vectors in radian or in degrees, let's say. Okay, let user enter angle in degrees and we'll be converting it to radian. Then the next line comes that we'll be taking input of that.
Ma'am, we have not created the array of angles.
Yes, so we need to create that array of angles. I'll be creating it just after I have created this array for force vectors, that is force magnitudes. So you can create many such variables which are of double type in one single line. You need not write every time that double F4, double A4. Okay, once you say double, then whatever is there afterwards separated by commas. So all those variables will be considered as double and will be declared. So you can declare angle as well as force magnitudes in the same line. You need not write a different line for that. Okay, so I have created angle variable. I have named it as A, and which is also a vector which has got 4 entries. So it is an array with 4 locations. Each location is able to store a double variable. Okay, a double number. So actually you don't even need a double for this, but that's okay. Single precision also would have done, but it's okay because angle values are not that large. So fine. So anyways, I have done this. So I will also be declaring that variable in which we are taking care of sum. So I'll be declaring that variable and I'll be naming it as a sum in x direction. Okay. Create one. This is for that step number 7. Create one float variable which can take this multiplication of force and cosine of corresponding angle. Okay. So now I am taking inputs of these angles. Similarly, in the same fashion as I have done over here for force, I'll be carrying out the same step over here. Okay. Only whatever that is getting inputted, I am storing it in that location where we have reserved that location for angles. Okay. So this is that scene command which stores angles. If let's say if you are writing a code and you are not going to be the end user, if somebody else is going to be the end user, and you want whatever that you are writing should be well understood by that person, whoever will be using or updating the code, then what we do is we create comments over here. So you can write down comments hereafter. So comment can be written in this fashion. You can have double the slashes. Okay, or you can have slash followed by a star. If you use double slash, then whatever follows and is in that line, only that is considered to be a comment. Okay, next line is not comment. Next line will be executed. Whatever follows it and is in that line, that will be considered as a comment. However, if you want to make or if you want to comment more than one lines, then what we do is we use slash followed by a star, and wherever we are ending that comment section, there will again be putting star and slash. Okay, so this entire region between these slash and star, that will be considered as a comment. Okay, fine. So if you want to write any comment that this is for taking angle input, something like this. Okay, which the next user will be able to follow. But it is not necessary if you yourself are a user. But let me tell you, when you are writing really a big code, then even if you yourself are a user, in that case also you need to have such comments, so that let's say it so happens, especially in my case, so we are developing our own finite element code, so we write our own codes in MATLAB. So that is not a single file. We have many such function files. So I work on one function file, so somebody else is working on some other function file. So we keep passing our files to each other. So the file that was created something like 2 or 3 years ago, I at times work onto it, open it once again. So at times I forget that what I had written, why it was written, for that something like 3 years ago I had written it, 2 years ago I had written it. And if I open it suddenly now, then I at times get lost that why it was at all written. So in that case, it is very essential for you to write down comments after writing any statement. Okay. Especially certain statements which are not that straightforward. Cout and all, you don't have to mention any comment over there. But if you're carrying out some activity, then why that activity is being carried out over there. So for that, you need to mention that. Okay, so cout, cin, they are pretty straightforward. So you get to know what is being done by that particular line. But otherwise, you need to mention that what that line is being written for. Okay. And that we do by inserting those comments. And how to insert the comments, I just now have told you. Okay, fine. So we have taken input of angles. We also have taken input of magnitudes of force vectors. So what we need to do further is, okay, so we are now at step number 5, where we are supposed to convert in angle variables, whatever angle values that we have taken in degrees, to radian. I will not be taking the step 5 explicitly over here. I'll be clubbing the step 5 with step number 6. Okay, so step number 5 will be executed at the same time when I'm going to execute step number 6. I'm not going to have a very different statement written for that step number 5. I don't want to unnecessarily waste my and computer's time in doing that. Okay, so let's go to step number 6. And in step number 6, what I have to do is I have to fetch one force variable. I'll be saying that, okay, fine. First force magnitude multiplied by cosine of, so cos is a function which gives you output as cosine of whatever input angle that you are giving. And in C, C++ and almost in all languages, input angle is supposed to be in radians. Okay, so over here I am writing down cosine of A0. However, I know that A0 is not in terms of what we want. It is not in degrees, right? So what I'll be doing is I'll be converting this angle to radians. It is in degrees. I don't want it in degrees. I want it to be in radians. So I have to convert it in radians. So how do you convert it in radians? You will be
multiplied by pi by 180.
You will be multiplying by pi and dividing by 180. So whatever is the angle value, okay, you will be comparing it 180, comparing that angle value with 180, and that comparison you are transferring to pi, right? So in the same comparison, you have to declare the angle in radians when you will be comparing with pi. Okay, so what you are doing is you are multiplying by pi and dividing by 180 degrees. That is 180. Okay, so if you want to multiply by pi, then one pretty straightforward thing is that we use what is pi, which is 3.14, but it is not 3.14, right? It's pretty big number. Okay, and it can exploit as much space as you can provide to it. So what do we do? So we don't do it in this way. We don't write down this 3.4, but we rather use this name. Okay. So this word is reserved by C++ and which actually represents pi. Okay, so its value is there. When you say m underscore pi, then it fetches value of pi. Okay. To that we'll be dividing by 180 degrees. Unfortunately, this is bad.
Ma'am,
Yeah.
ma'am, for using cos, we have to include
Yeah,
math.s.
I have intentionally not talked about that yet. Okay, so I was about to show you that there is an error because we have included only IOStream header file so far, and IOStream header file is that header file which takes care of only input and output related functions. Okay, so it doesn't understand what exactly cost function is. Okay, or so for that purpose, what you need is you need another directory over here which can take care of this cost that you have written over here, and that directory in C it is math.h, in C++ it is C math.h, C math, you don't write h thereafter, so we'll be calling that C math. Okay, so what exactly this cost is, what computer has to do when it encounters this cost, that is there, that actually this C math will contain what is the syntax of this cost. So this syntax and everything else can be fetched if you include this directory over here. Okay, and namespace is still std. What the namespace is, I'm going to talk about it later. But otherwise, you would have even mentioned whatever namespace this course requires. But it is this std would do the job, and you don't have to declare that. Okay, so this much needs to be done. So step number 13, line number 13, whatever that we have written, that line number 13, what it has done multiplication of f0 and cosine of that angle. Okay, but now you need to store this multiplication somewhere, right? That multiplication value will be stored at a location which is called as sum underscore x. That so the first, this line number 13, what it will do is it will go over here first, it will see that f0 and this cosine term that needs to be multiplied by, so it will execute what exactly this cosine of this angle is, and it will multiply by this f0 to that value, whatever is the answer of this particular instruction, and multiplication will be stored over here in sum x. Okay, so whatever space in the memory that you have reserved for sum x, there this multiplication value will be stored. Okay, so is line number 13 clear?
Yes, ma'am.
Anybody else? Is there any problem? Is there any problem at anybody's end?
No, ma'am.
Okay, fine. Okay. So the next line, okay, I can even declare another variable sum y to take care of resultant force in y direction. I will be writing it down in this way. Sum y is equal to f0 into, this will be sine of this angle. Okay, so okay, fine. It has taken care of only first forces resolution in x and y direction, but you need to resolve other forces too, and you need to add them in whatever that you have obtained over here in that variable. You will have to add them. Okay, so that is the step that I am going to carry out hereafter, which is the step number 8. Okay, keep carrying out step number 6 for all force magnitudes and magnitudes that you have and corresponding angles. Okay, so let's try to do that. Okay, so what I'll say is that sum x, okay, now in that location which is reserved for sum x, you need to store something else. And what is it that you need to store? You need to store summation of two things. First of which is the variable which is already there in the value which is already there in this variable location sum x. Fetch that value first, okay, and to that value add f of 1 multiplied by this cosine. What is this? Only a0 will be changed to a1. Okay,
Ma'am,
Cosine
we
of
could have directly used the for loop.
Others are unaware of what is for loop. So I'm going to tell what for loop is in the today's class itself. So for others, those who don't know for loop, they at least need to know why loops are required. So let's first of all write individual statements for all individual forces, and then only I'm going to go into for loop. See, there are people who are completely unaware of C++ and or what these loops and all are. So from their perspective, I need to go in a particular stepwise fashion. Yes. So somebody was asking me some question. Yeah.
Ma'am, can't we merge 13th and 15th step? Like in 13th step, can't we write sum x is equal to f0 that plus f1 plus f2 like that?
You can do. You can actually you can carry out that step in that fashion. So you can write summation of 4 such multiplications. So this plus the same stuff with only 0 change to 1 plus same stuff 0 change to 2 plus same stuff 0 change to 4. But let's say if you have hundreds of them, then you will have to write down such 100 number of summations over there, and that we don't do it in that fashion, but rather we do it in this fashion. And this is the motivation for that for loop that somebody was just now speaking about. And since I want to go to that for loop and I want that motivation to come to the surface, so I am doing it in this fashion. Indeed, there are other ways of doing carrying out the same activity. Okay, this is the dumbest way of doing, but I have intentionally followed that dumbest way. Okay, fine. Is it clear to those who absolutely don't know any, who don't have any prior background of programming, that what this step number 15 has done? Okay, because it has got some x sitting on both the sides of equal to sign. So what it has done is some x actually is name of variable. Okay, there is no any value as of now. I mean, it doesn't refer to a value, but it refers to a variable, and that variable can contain any value. Okay, as of now, whatever is the value in that sum x, okay, what we are asking that this particular computer to do is take that value, and to that value add whatever is this one. Okay, so add this to the value which is stored in sum x, and whatever addition comes out to be, that addition will now again be stored at the same location, sum x. Okay, now earlier value has been erased off. Now sum x will not contain earlier value, but it will contain a new value which is equal to earlier value plus this multiplication. Is it clear to you? Those who don't have any background, is this step clear to you? This is very crucial step. You need to understand this.
Yes.
Yes, ma'am.
Yes.
Okay, good, very nice. So it's clear, and now we'll go to the next step. So we need to carry out this for all rest of the angles, and it is pretty boring. So, but we need to do that job, and we'll be doing that job by changing 1 to 2, 2, and this will be changed to 3 over here. Right, this is the only change I'm doing in each step, right? Step number 15, step number 16, step number 17. What is the change? I have only changed 1 to 2 to 3. Okay, I can even rather change step number 14 in this way. Okay, sum x, when you declare some x variable in C++, it is giving we give default value 0. Okay, so this computer is automatically doing it, so it is automatically initiated to 0 value. Okay, so that's why you can write it, but there are some in some languages some garbage value can also get passed to that. Okay, so if you want to be very sure that you don't pass any such value, then what we do is we initialize it to 0. Okay? If you don't know whether this initialization has really given it a 0 value or not, then you better initialize that sum x to 0. If you do so, then only step number 14 is having the same meaning that you were anticipating it to have, right? Clear? I need feedback. I'm not able to see you people, so I need feedback from your side.
Ma'am, in 14th step, you have at some y equal to some x.
Oh, sorry, it's actually some x. I have mistakenly written. Okay, we are not into some y yet. Okay. Is it clear to everyone? Huh.
In the 13th line, some x equal to 0. We could have omitted this step now.
Actually, it can be omitted. It is not necessary. Whenever we declare a variable, okay, it is kind of initialized to 0 over there itself. Okay, but in a certain at times, what happens? You can you use the same variable many times. Okay, and it may happen that that variable was used earlier and it was given certain value at that time, and it now still the same value is over there in that variable. And if let's say if you happen to use that variable once again, then you need to initialize that variable. Otherwise, if you are using the variable for the first instance, then you can certainly get rid of this line. It's not required. But when you are not sure whether you have used that variable before, or if that whatever, even if you have used the variable, if you have kind of changed its value back to 0, if you are not so sure about that, then you write this line. Okay.
Okay, ma'am.
Okay,
Ma'am,
but
it is compiler specific. Means in my compiler, if I actually do not write sum of x equals to 0, then it gives uninitialized variable used, and that gives an error.
slightly, I don't think it should be, but if it is so, then you better initialize it. Okay, but this is a
Ma'am, we can
general and typical
initialize
practice.
it equal to.
You can
Ma'am, we can
initialize it.
initialize it as equal to 0 in the first line where we declare it, the 8th statement.
Yes. While declaring itself, you can initialize. That can also be done. So at the time where you are declaring that in that line itself, you can initialize. That can also be done. That is very well possible that you declare it and you initialize at the same location. So that is very well possible. But initialization is considered to be a good practice of programming, because you don't believe so much into whatever that is happening in the background, right? So something which is black box to you, better don't believe in it. Okay? So let everything be clear, then you are assured that whatever is going to be the answer, that is right. So at times you don't have any benchmark to check with that your answer is right or wrong. Okay, so let's say if you're working on a research problem, you don't have any answer with you. So in those cases, if you don't want to make any mistake, then it's better to have your program written in as neatly possible, neat way possible. Then only you can be assured that okay, fine, whatever is the final answer is right. So at least there shouldn't be any programming mistakes. There can be mistakes which can be from logical perspective. So the way you have written this itself may go wrong. Okay, so if it is wrong, then that is a different issue. Then that can be resolved. But there shouldn't be any problem in after writing this, when you convert it to program, at that time there shouldn't be any issue. So follow better programming practices and initializing variable where you are which you are using again and again, and to which you are passing value and updating that variable. So that initialization of that variable is essential. Okay, so that's why I have written this line number 13, but as somebody had just pointed it out, it can be included in line number 8 itself. Okay, you could have initialized to 0 over here itself. Okay, so that can be done. Okay, so this is what I have done. So let's run it and let's try to see whether you get the same answer. Okay, so I also need to print.
Ma'am,
Yeah.
ma'am, in 14, sign can be sign with cos should be
Oh,
there.
I had mistaken. I had written that. Yeah, there's some y I had written. That's why it has happened. Okay, fine. So everything has to be cost, and I will also be printing this. So I'll be saying that resultant force in x direction is. Okay. And then I want some x as the output on the screen. Okay, so shall I run this program? Let's try to see. I'm compiling and running it, and let's try to see if it does the job. Yes, it is asking me for force magnitudes. So I need to see what that problem is. So you have this force number 1, which is having 150, then 80, then 110, and then 100. Okay, so it is 150, then 80, then 110, I guess, right? And then 100. And then 100. In input angle of force vectors in degree. Okay, so we have to consider angle with respect to positive x-axis. That also you can write down where you are writing the statement. There you can specify that. I guess we had talked about it yesterday. That will be, we have to write down that input angle with respect to positive x-axis of all force vectors in degree. Okay, so what is the first angle? It is 30, right? Second angle is 110. Third angle is 270. And what is the fourth angle? 360 minus 15, which is 345. Is it right? And the answer is 119.135. So try solving it and check it whether it is right. Is it the correct answer?
350 should be the fourth angle.
Fourth angle should be, it's minus 15 degrees. It's not minus 10 degrees. Right, so 360 minus 15, which happens to be 345, right?
Yes, ma'am.
So is the answer correct? Has anybody checked it out?
Yes, ma'am.
Yes, ma'am, I'm getting the same answer.
Right, you are getting the same answer. So our computer is wise now. It can solve our problem, mechanics problem, right? So you have made it wise, right? Are you getting what have you done? Right. So what we have written over here. So are you able to get it? Okay. So as somebody had suggested, we can even make this program pretty crisp than whatever right now it is by writing something called as a loop. Okay, something which as any action which keeps on repeating many times, we keep that action in a loop. Okay, we write down a statement or a set of statements which are called as loop, and in that loop we'll be carrying out that repeated action. Now this set of statements from line number 15 to line number 18, 15, 16, 17 and 18. So these 4 lines, they are almost identical one, right? So we just change 0 to 1, then 1 to 2, then 2 to 3. That's the only change that we have done. So we can write down this in crisp format. Essentially, computer is doing the same, that will be doing the same stuff, okay? So it is going to take 15, 16, 17, 18, these steps only. But we will be writing it in a very crisp format. Why it is required? Right now, there are only 4 force vectors which are acting onto it. Let's say that there are hundreds of them. Then how would you do that? Okay, so you won't be able to write down all those 100 statements. I mean, somebody will certainly be able to write down, but it is really boring and unnecessary time consuming. So we don't get into that stuff, and we write it in a very crisp format, which is called as looping. And so we write down that loop over here. There are various loops which are available. Right now, I'm going to show you one loop which we very popularly use, and that is called as a for loop. Okay, so you need to carry out action which is there in that loop for certain value, for certain number of time, and that is what we are going to tell over here. Okay, so for till what time you are going to carry out? Till you start from 0 and end to 3, right? So we'll be declaring one variable over here, okay, which I'll be calling as I. I is the popular name of the variable which we use inside for, but it need not always be I. You can use any variable name. I'll be saying that I is initialized to 0. Okay, I has to till that you have to carry this action till the time I is smaller than 4, and after each step that you have carried out, you have to increase the value of I by 1 value, right? I will be changed to I plus 1. Okay. So in the first instance, I will have value equal to 0. Then it will carry out the action which we are going to write over here inside these curly brackets. Then once that action is carried out, once all those statements inside these in these two curly brackets, those are executed, then the control will go over here, change value of I to I plus 1. Then again it will carry out the same stuff. Again it will change the value to 2. It will go over here, carry out this. It will keep doing so till the time it meets this condition. Okay. Okay. When it till the time I is smaller than 4, it is going to carry out whatever is there in this set of curly brackets. So the moment this is not satisfied, this loop will stop running. Okay, so this loop has to run from I equal to 0 to I smaller than 4. Is it clear what I just now have said?
Ma'am, in C, this I is equal to, ma'am, it becomes I plus plus. Is it how this is written in C plus plus?
You can write it that as well. So plus plus means plus 1. Okay,
Yes, yes.
Increment by 1. So that's why C plus plus means that increment of C by 1. Okay, it is next C. So that's why they name it as C plus plus. Even if you write plus plus here, that would mean the same stuff that I just have now written. I have added 1 over here. But when you just want to add 1, then you can rather write plus plus. Okay.
Okay.
But not always you add by 1, you can add by 10, you can add by any other number, right? But as of now, it is in most of the cases, it so happens that we increment value of I by 1, and that's why we write it as I plus plus. So I plus plus would also do the same. Okay, so what it is this control is going to do, I'll show you, I'll tell you in detail. Okay, so let me write down that statement inside this. Okay, and now wherever I'm encountering this variable f of 0, wherever I've written that 0, I'll be changing to I. Okay, here also I'll be changing it to. Okay. And now I'll get rid of all other statements. Okay. So it is exactly identical to what we have done earlier. Okay, so let's say that initially we are over here, and then we end up over here in line number 14. Then line number 14 will see that, okay, fine, it is a for loop. So what for loop has to do? So these are a set of lines that for loop has to execute. Now these lines will have variable called as I. That variable is this is declared, and this is initialized to 0 over here. Okay, so once this is initialized to 0, it will go in. Okay, if let's say if you declare this variable to 5, that it won't go in. Okay, because 5 itself is larger than 4. Okay, so you have to declare it to 0. Okay, by mistake at times we do that way. So ensure that this is smaller than what is the condition. So this is the condition. Till the time this condition is met, okay, so all this stuff is being executed. So is it being satisfied? Is this condition being satisfied? Yes, it is satisfied. So execute this. Okay. So
Excuse me, ma'am.
see, yeah.
Ma'am, in the for loop, you have given an unnecessary semicolon, I guess, at the end.
Yeah, that semicolon is not needed after I plus 1.
Okay, fine. Okay, so I actually don't use C++ much, so I am not that conversant with this language. So we don't even write it in this fashion. Okay, so we write for loop in a very different fashion. Okay, but anyways, so if it is so, then we'll get rid of it. So I don't know. Hopefully that this will run. Fine. So what I was saying that okay, so then the control comes in control and this line is executed. Then again, after you come out of it, you will again go over here. Okay, and this time you will be going over here, changing the value of I to I plus 1. Okay, so whatever was the value of I, that value will be incremented by 1. Okay, in after you are done with first step, your value of I is still 0. That value will now be changed to 0 plus 1, which is equal to 1. And it will see whether the condition is satisfied. Yes, condition is satisfied. Still I is smaller than 4. Then control will go in control and this line will be executed. Then you will come out of it. Once you come out of it, then you will again go over here. Will increment I to next level, which is I plus 1. This time I was having value equal to 1 and you have to increment it one step further. So new value of I will be 2 now. It will check if I is smaller than 4. Yes, I is smaller than 4. If I is smaller than 4, then it will go in, execute whatever is there inside, and it will
If
keep
we
doing.
define some underscore y as well within the for loop, will it execute?
Yeah, it will execute. So I'm going to do that. So we can, as I just have now said, we can write down the same stuff over here. We'll be saying that some y is equal to some y plus you need to add some some y over here. You need to be very careful about all this. And only sign is to be written over here at the place where cos was. And then rest of the things are same. You initialize some y as well to 0. Okay,
Yes, ma'am.
fine. And you can even give indel here. Then I'll be writing down the same statement. I could have written it in one single line, but then that would not have been visible. That's why I'm not writing it over there. And resultant force in y direction is some. Okay, so let's try to see whether we are able to execute it. So is there any query before I execute?
What is end one you wrote at the last?
That is essentially new line and flush. So flush is whatever is there in that variable, that value is stored in hard disk. It gets
Use of
flushed.
Ma'am, use of /t there.
This /t is for space. Okay, I want some space after this colon. This is for tab. Okay, so as much space as you put when you put this tab when you press this tab button, then that much amount of space is printed over here on the screen if you write down this. Otherwise, you could have done it like this. Okay, but I better prefer it in this fashion. Okay, clear?
Ma'am, why semicolon is not used after the for line?
Here?
In the 14th line. Yes, ma'am.
Because this entire set of lines is actually the for loop. Okay. So it doesn't end over here. It ends only after this curly brace is over.
Okay, ma'am.
Okay, and you don't need, I guess at least we don't write it over there in MATLAB, so I don't know whether we need, I hope that we should not need semicolon here as well. Let's try to run.
Some semicolons are for statements.
Those are for statements, so those are not for loops and all. So good. Okay, so let's run it. So there is no any error in it. So at least it is executing what we are asking it to do. But let's try to see whether it is executing appropriately. Okay, so let's try to input those values. So which was, yeah.
Ma'am, why didn't we input the force magnitudes in the initial program only?
We could have done that. It's not like that you can't do it, but then that is written only for that, right? So let's say if I change the value, then what would you do? You want your program to be a generic one, right? So user can input any set of force magnitudes, any set of angles. Okay, I will also be showing you maybe in next class or sometime later that even you can ask the user that how many number of forces are there, and accordingly you are going to store those many number of places over here. Okay, you will be reserving places accordingly. Why do we need 4 if at all only 3 number of forces are acting onto it? Right?
Ma'am, is it necessary to put I less than 4? If
sorry.
Ma'am, I should be less than 4. Is it necessary to give this value?
Yeah, it is necessary because it won't understand. It will see what it will do is after, let's say, if you don't, essentially it is necessary. It is the syntax that for is having. So you have to include some statement over your conditional statement over here, which so what this does is it compares the value of I with 4. Okay, and if the statement is satisfied, it gives either 0 or 1. I don't know what gives it over here. I suppose it is giving 1 if it is smaller than 4, and if it is giving 0 if it is greater than 4 or even equal to 4. So in that case, that control won't go in. Okay, so whether whatever statements are there inside, should they be executed or not, that depends on what is the flag which is generated over here. That flag can either be 0 or it can be 1. Okay, so you need some.
It's not necessary that I'm always going to evaluate a force having 4 different forces on a body. It can be more than that. No?
Yeah, so let's say if you happen to have 10 number of forces over here, okay, then I'll be writing 10 here.
No, ma'am, I have a program that can be generalized for n number of forces.
Right. So you will be asking initially, that how many number of forces are there. You will be storing that value in n, and you will be declaring this vector for those to contain those many number of double values, and that n you will be taking over here. Okay, you will be writing it for n. That way you will be doing. Are you getting it?
Yes, ma'am.
So you can do it. So rather that's how it is done. Okay, you don't have to fix it to this. Okay, but we are starting it from a scratch, and hence we have declared it that there are 4 number of forces in the beginning. But this need not be fixed. Okay, as I just now have said that one can input any force magnitudes. In the same fashion, one can have any number of force vectors as well, right? So that how many number of force vectors those are going to come, that needs to be asked to the user. User has to input that, and once that user gives that input, then accordingly you will have to carry out rest of the program. Okay, you can generalize it in that way.
Yes, ma'am, got it.
Okay. Fine. So let's try to what I was saying. I've forgotten. What was it? Yeah, we were executing the program. Yeah, we are in the middle of that execution and we are inputting these values. Okay, so the first force magnitude is 150. Thereafter we have 80. Thereafter we have 110. And thereafter we have 100. And now input angle of force vectors in degrees, it is 30, 110, 270, and 345. Is it right? Resultant force in x direction and resultant force in y direction. Check it out.
Yes, ma'am. It's correct.
It's correct, right? Good. So are you able to see what is it that we have done over here? Okay. So I hope things are clear to you.
Yes, ma'am.
Okay, okay, fine. So let me come out of it. Now I will pose one more question over here. So what I want this program to tell me that whether this body is in equilibrium, or if not, then it needs to tell me that in which direction it is likely to move, or in which direction there is unbalanced force. So what should we do? So what do you do if you want to check whether under these external forces, whether any resultant force is coming onto the body or not? I want to check it out that if there is at all any resultant force coming onto the body or not. So what do you do?
How to use if else?
If else,
It
we'll
was a
have to use
check
if
or
else.
loop, right?
Can somebody speak only one at a time?
Ma'am, we use if else statements.
Okay, so okay, you are telling it from the perspective of this code itself, but let's say we are in this pseudo code. Okay, so what we do is we compare that value, right? I wanted that answer, that we compare whatever is the output, whatever is the sum x and sum y you are getting. So we'll be comparing sum x and sum y with what? With 0, right? Right or wrong?
Yes, ma'am.
Yeah.
Yes.
So you will be So you will be comparing value of sum x and value which is there in sum x, value which is there in sum y with 0. Okay. If it is equal to 0, then body is in equilibrium. If it is not equal to 0, then or more than equilibrium, I would say that there is no any resultant force acting onto it in that direction. Right? So we will say that there is no any resultant force acting in x direction if sum x is equal to 0. If sum y happens to be equal to 0, then we'll say that there is no any resultant force acting in y direction. Okay. Otherwise, we'll say that there is some resultant force acting in x direction and in y direction, and then we can say that that resultant force is equal to this much. Okay, so we need one comparison statement. So that comparison statement is taken care of by if statement in this. So we'll try to see how that if statement is. In that pseudo code, we'll be writing that compare values of resultant force components with 0. Right? So this is something that we'll be doing, and accordingly we'll be taking the decision if comparison is true. If true is the answer, is it equal to 0, true or false? It will be telling, yes, it is equal to 0. So it is true. If it is true, then no resultant force in that direction. Right? Otherwise, I'll remove this. Otherwise, print on screen whatever resultant force is acting in that direction. Okay, So we need to add it over here. So we will be adding if statement here. So what we'll be doing is I need to know syntax of if. How is it? If just check it out if it is right. If some x, I'll be writing as we do over there in MATLAB. But I don't know if it is true over here. Is this how we write in C++? Those
Yes, ma'am.
those who know, yeah. Then I'll be writing down that if some x is equal to 0. Okay, so when you say single equal to sign, then what you do is you do the job of assigning. So whatever is over here, that value is assigned to whatever is the variable on the left hand side. But you don't want to do the job of assigning over here. You don't want the 0 value to get stored in some x variable, right? You don't want that thing. What you want is you want to compare whether the value which is there in some x is equal to 0. Okay, when that comparison is to be done, at that time we use double equal to sign. Is it clear why I have written equal to 2 times equal to? Is it clear?
Yes, ma'am.
How it is different from single equal to? Is it clear? Is there anybody over here who is not able to understand at all what is happening?
Ma'am, once can you repeat the point?
Yeah, I'll repeat it. Okay, so when so let's see over here. Okay, in this step number 13. So what is it that this statement doing? Okay, it is giving this value 0 to this variable, right? It is assigning that value. When you write down equal to between some x and 0, then what is happening is that whatever is there on the right hand side, that is assigned to left hand side. Okay. So when you use single equal to, that time assignment job is being done. So do you want your value of some x to be changed over here? No, you just want to compare whether the value of some x is exactly equal to 0 or not. Right? Now, in order to do that, we'll be including equal to sign over here. Okay, so that's why we have to use equal to 2 times equal to. Please turn the mic off. Turn the mic off, please. Ujjwal, turn the mic off, please. Okay, so I hope things are clear to you how exactly why I have used this double equal to sign over here. Okay, this is for comparison. Okay, if this comparison is true, please Ujjwal Saraswat, your mic is on, I guess. Turn the mic off. We are anyway don't have yeah, we are running out of time. We don't have time anyhow. Okay, so I'll be only writing down the statement and we'll stop over here. Okay, so I am writing down that there is no any resultant force in x direction. Okay, so this is what I have written over here inside this. If some x is equal to 0, then there won't be any force in x direction. That will be printed on the screen. Now, if this doesn't happen, then I don't know how exactly this if else works over here in C++. Let's try to see whether the control comes directly here. I need to check it out. I'll check anyways and we'll let you know whether it happens that
Yes, ma'am, it comes like this only.
right, no? Okay, so this will be the statement else. Okay. Similarly, I'll be writing it for the same set of statements. I'll be writing it for someone. . Here I'll be writing in y direction. Here it will be y. This will be changed to y. And this statement will go away. Line number 35 will go away. And this is the end of the program. Okay, so we have done this, but there is going to be one problem in it, and I'll be showing you that in most of the cases you won't see, even if you anticipate that sum x to be 0, you will see that it doesn't go inside. Okay, it fails to understand that sum x is equal to 0. Why it happens, we are going to talk in the next class. We are stopping over here. Okay, so I hope that you people have understood most of the stuff that we have discussed in the today's class. If you have not understood, then please go through whatever that I have said over here in the class. I'll be uploading the lecture once again. Have a relook at that and try doing it at your end. Okay, fine. Yeah.
Ma'am, in the line where you declared array as well as sum x, ma'am, so what is exactly the meaning of double? Means it is declaring variable that sum also
Variable format. So array, which is this f is an array of those variables which are of double type.
Ma'am, what is that double meaning? Double type.
Double is that IEEE double precision format. I have told you, right? So how much space it allocates and how much big that real number it can store.
Ma'am, but here we have small numbers, so we can use
So
float also.
you can use float. You can use double. You can use that. Okay.
Okay, thank you, ma'am.
Welcome. Okay, so I'm here.
Ma'am, in tutorial sheet, you have to submit 2 files or only 1 file?
This time you can submit actually multiple files, but still I would prefer that you submit single file. Single file submission is preferred one. But let's say somehow if you fail to do that, then you can have multiple submissions. Maximum files that can be submitted, I guess the limit is set to 5. Okay, so maximum 5 number of files you can submit, but preferred one is one single file. Okay, then it will be evaluated properly. Obviously, in certain cases we'll entertain even if you fail to submit one single file, but if every one of you submits many more files, then keeping track of it at times can be difficult. So in order to save our life and in turn your life, I request you to submit one single file. Okay.
Ma'am, you have done only till question number 6.
First tutorial.
Yes, ma'am.
Why so?
Ma'am, in 7 question, there are definitions, and in 8, 9, 10, we are unable to do complex problems.
So which batch you are in?
Q4.
So is it the case with everybody in Q4? It has been discussed in detail for Q4 tutorial batch as well, right? We have discussed it in.
Yes. Till question number 6 we have discussed.
Why so? Q4 batches tutorial is on Tuesday. That was yesterday, right?
Yes, ma'am.
So did I not conduct it? It was conducted, right?
Ma'am, Parash is saying about tutorial number 2nd.
I is talking about tutorial number 2nd. Okay, fine. That no issues. Okay. So that you will be submitting afterwards.
Okay.
Okay, I forgot. I thought that I failed to conduct your tutorial yesterday. Okay, fine. Okay, so please don't scare me. Okay, thank you. So we are stopping over here, and you can see the recorded lecture very soon. It will be uploaded. It's still some query, I guess. Yeah, please. Whenever you will be done discussing that tutorial too. So if let's say you are from Q4 batch, then your turn will come next Tuesday. So by next Wednesday or so, you can submit the tutorial. If you are from Q5 batch, then your turn will be this Thursday itself. I guess you will be having your second tutorial. and in that case, you will be submitting by Saturday, I guess. Yeah, one more very important thing that I want to tell you is that day after tomorrow we have class at 12, right? But though that day we have PhD interviews scheduled, and I'm going to be busy in that interview session. I have to take interviews of candidates who are appearing over here for PhDs. So I won't be able to engage your class on that day at that time. But we'll make out for the class if it is possible this Saturday. Is it working Saturday this time as well?
No, ma'am.
So, would you prefer having 1 hour class this Saturday?
Ma'am, in the Friday.
Yes, ma'am. It is okay.
Friday should be okay. So tomorrow and day after tomorrow we have classes. So Friday, do you have any free slot?
Ma'am, we have a class.
We have a class, right? We have a class. So before that class, are you free?
Friday is free.
Yeah, so we can conduct 2 hours class in that case if you are okay with it.
Friday 9 to 11 also we are free.
No, but I'll try to conduct it along with our scheduled class, so which is from 12 to 1. So before that, so from 11, is 11 to 12 slot free to you?
Yes, ma'am.
No, ma'am.
Yes, ma'am, because Math sir has
Yes, ma'am,
cancelled.
because Math sir has cancelled the classes.
It must be because of PhD interviews itself. So because we are having PhD interviews everywhere in our institute, so he might have done that from that perspective itself. So if his class stands suspended, then I'll be having your class scheduled on the same day at from 11 to 12, and then from 12 to 1. Okay, 2 hours at a stretch.
Which class you have cancelled?
I'm oh yeah. So it's Wednesday. Just a minute. So it's Wednesday today, right? So okay, fine. So I'm canceling Friday's class. So how can I have one more class on Friday itself? Yeah. So because we are having 2 days interview session, so Friday's class stands suspended for me as well. So you are not having a class on Friday because I'm going to be busy in PhD interviews on for next 2 days, which is Thursday and Friday. So I'll be able to take your class only on Saturday, this Saturday. So Saturday is the only time.
Monday you can take Monday 12 to 1.
Monday we already have a tutorial from 2 to 4.
Yeah, it will be too much of C++
Ma'am,
for you.
You can think of Saturday also, ma'am.
Yes, ma'am, Saturday is
Yes,
okay.
ma'am. Saturday
So
would work.
is anybody having any weekend plan for the Saturday, and that's why reluctant? Okay. Okay, fine. So let's have it on Monday because I don't like my weekend to be spoiled, so I don't want anybody else's weekend also to be spoiled. Okay, so we'll prefer it on Monday. It will be too much of C++ on Monday for you. So but anyways, so we'll be having it. So what should be time for Monday? What is the free time?
12 to 1. 12 to
Ma'am,
1.
5 to
1.
6.
5 to 6. Are you
Ma'am,
okay
12
with
to
that?
1.
I'm okay with any of these 2
Yes,
timings.
ma'am.
5
From
to
5
6
to
or
6.
5. Okay, so CR, you have a word with all students. You take the call and majority wins, and tell me whether from 12 to 1 or 5 to 6 and write to me. Okay?
Yeah, okay, ma'am.
Okay, fine. You will be writing to me, and accordingly I'll be setting your meeting. I'm stopping our session here.
Thank you.